talk about walking or hopping in birds. Okay, so when we think about birds, usually we think about flight and feathers and wings and the ability they have to move in the air. But I would like to draw your attention here on the fact that birds can also do a lot of different type of locomotion behaviors. They can walk, they can run, they can jump, they can perch, stay on one leg forever, they can even sleep with just one leg. And they can also take off and land, they can paddle and swim. And yes, they can fly, but as you can see, they can do also a lot of other things. And what is interesting is that on these other locomotor behaviors, they use pretty much always their legs and not their wings. So this is why I'm interested in terrestrial locomotion and in the pelvic girdle, so the hind limbs, the legs of the birds. And when we think about terrestrial locomotion, there are mainly two groups, walking and hopping. So for walking, it's pretty easy to imagine what it is. It's pretty much like the human locomotion with the two legs moving out of phase. And for hopping, you have this little bird doing pretty much like a jump with the two legs in phase. And when we think about terrestrial locomotion, we can also think about running. And so you can see that there is also a very nice adaptation to this locomotion style. But it is pretty easy to imagine what is the relationship between walking and running, because it has to do with the increase of velocity. But what is the relationship between walking and hopping? It's a bit more complicated, because usually the birds are only doing one or the other. They are either walkers or hoppers. Some of them are doing both, but it's pretty rare. And so what I wanted to investigate is the evolution of hopping and in the history of birds. So when we look at phylogeny, for example, here is 96 species. I have mapped from the literature or the observations the locomotion style of those birds. So in orange you have the walking birds, and in blue the hopping birds. And as I said before, you also have birds that are doing both. And we can see that the more basal birds, so padomats, anseriform, galliform, up to stratiforms, are doing this walking locomotion. And when we think about the ancestors of birds, so the theropod dinosaurs, we have good evidence to know that they were walkers. So walking is the ancestral stage here. And the passeriforms, which are the most diverse group of birds, are hopping birds. And you can see that in the middle it's a little bit complicated, because you have pisiforms that are mostly walking birds, and pisiforms like the toucanos, who are hopping birds. So you can see that if we do parsimony reconstruction, you have several occurrences of this hopping ability in the evolution of birds. So I wanted to investigate a bit more and try to find what selective pressure has driven some groups of birds to start hopping. So because most passeriforms are hopping birds, and because they are small, we usually think about the size as a parameter, as a good parameter to explain why some birds have started hopping. But there are many counterexamples, such as this little bird that you might see here in Brazil. It's very common, Turdus rifibentris, which is small, but which walk. And you also have the ravens, which are big, and they can walk, but they can also hop. You will see it in a minute. And well, it's pretty striking for such a big bird. And you also have the green parakeet here, which is small and which is a walker. And you can also see that he's doing other things with his leg. As I said before, legs can do a lot of things in birds. Okay, so size is not exactly... okay, stop. Can you pass it? Okay. So when we map the locomotion style with... doesn't work. With the size, we can see... Okay, it doesn't work anymore. You can see that there is, yeah, you can, no, can you come back? Okay. Yeah, it will be difficult. Or I can do it maybe. Can you come back? Okay, so you can see here on this phylogeny that you have a group of birds which are small, but they can hop. The other ones are big and they can also hop, so it's kind of complicated to find a good trend here. And so I thought maybe there is another parameter that we can use to try to understand this evolution of the hopping ability. And the nesting habits, which could be a proxy for the locomotion style and the living style, such as the arboreal lifestyle of bird, could be a good parameter. So when we map the place where the birds are doing their nest, we can see that when they are doing it on the trees, it starts to be the evolution point where the birds are starting hopping. So I wanted to investigate what are the relationship between the morphology of birds, of the skeleton, and especially of the pelvic system. What are the morphology features that can be related to the ability to hop and maybe to an arboreal lifestyle? So most of the time, people are using the three long bones, so the femur, tibiotarsus, and dorsometatarsus, and try to measure and calculate the proportion of the length of those bones to map it to with the lifestyle of the birds. But I thought that the pelvis is also a very important bone in the pelvic girdle, as it is the area where all the muscles, or most of the muscles of the legs are inserted. So I took the same phylogeny, and I've chosen 90 species of birds that are representative of this phylogeny with different hopping or walking abilities. And then I did some CT scan of those birds. And I got 3D skeleton, virtual skeleton, and I did geometric morphometrics on it. So I've chosen 82 homologous landmarks on the pelvis, femur, tibiotarsus, and dorsometatarsus to describe the shape of those bones. And from this digitizing procedure, I have done a purposed superimposition to get some data to do statistical analysis. So because those specimens are phylogenetically related, I used phylogenetic MANOVAs to check if the differences in the shape of the different bones that I was saying were significantly different when we take into account the phylogeny. And what I found is that the phylogenetic MANOVAs indicate that there is an influence of the hopping ability on the shape of the pelvis, but not on the shape of the femur, tibiotarsus, and dorsometatarsus. So when we look at the principal components analysis for the shape of the pelvis, the PC2 and 3 are significantly different when we take into account the phylogeny, I already taken into account the size of the birds. And you can see that the walking birds in orange and the hopping birds are pretty well separated by this principal component analysis. And in the middle there is always the birds that are doing both. So it seems that it is consistent with what we thought. There is some shape related to the ability to walk or to hop. And when we look at the consensus along the third principal component, we can see, so it's in gray, you can see that the walking birds, or at least the birds that are more up in these principal components, they have a narrower pelvis, and so the hopping birds have a broader pelvis. So this is something that is still an ongoing work, and I would like to dig a little bit more to see exactly where the differences are. And when I tested the influence of the lifestyle on the shape of the other bones, I found that there is an influence of the arboreality on the shape of the femur and tibiotarsus, but not on the pelvis, nor the tarsometatarsus. So there is also something interesting here, because when we look at the morphology of the pelvic girdle, we see that the muscles are mostly inserted in the proximal part of the leg, so mostly on the pelvis, and also a little also group on the proximal part of the tibiotarsus, but there is no muscle attachment on the tarsometatarsus, which is more ligaments and tendons on this part of the leg. So maybe this is why we don't see really a difference in the shape of the tarsometatarsus, and maybe there is something to dig a bit further here. So to conclude, the evolution of hopping happened after a walking ancestral stage many times in the history of bird, and there is a link with arboreality, and the shape of the pelvis girdle is linked to the ability to hop either with the pelvis broader in a hopping bird than in walking birds, and also it's linked to the arboreal lifestyle, mostly on the femur and tibiotarsus. And as I said before, the tarsometatarsus doesn't seem to respond that way to this kind of test. And for the perspective, because I told you it's ongoing work, I would like to have more species in the sample to have a more accurate view of this evolution trend. And also I would like to perform 3D geometric morphometrics analysis with sliding landmarks, because I have everything I need to do that with the CT scans. And I've already dissected all of these specimens, and especially the 42 muscles of the pelvic girdle. So I would like to use those data to see if there is a link with the origin, insertion, and also fiber lengths or the weight of the muscles, to perform a biomechanical modelization of the pelvis girdle to link the shape with the motion in an evolutionary context. So I'd like to thank all these people and you for your attention, and I will take questions.